All right, so we are doing indicator 1.3, which is absolute values, and I will give you some steps to follow here in just a minute, and then we will work a couple of practice problems, okay? So as far as steps, I really only give you 3, and I kind of abbreviate here. So step 1 is going to isolate, and I'm going to get lazy here, the absolute value. Okay, and I'm just going to put an X in the middle. I don't care what's inside the absolute value brackets. Isolate means to get it by itself. So you're going to move things around off of the left side of the equation. You're going to move them to the other side of the equation so that the only thing on the left side of the equation is just your absolute value. Whatever's in it, it doesn't matter, but just your absolute value is by itself. After that, after that, you are going to set, and I'm just going to put X, but it's whatever's in the absolute value. Okay, set X equal to a plus and a minus, and that will make a lot more sense, I promise, once we do it a couple of times. But for now, just kind of jot this down so that when you go to do it, you can go back to your notes and kind of remind yourself. And then step 3 is to work twice. Okay, so step 1, isolate your absolute value. Step 2, set whatever's inside the absolute value equal to a plus and a minus, and then work it twice. And I'll show you kind of what that looks like. All right, so for number 1, the absolute value is already isolated. So step 1 is done. Okay, and I'll wait a second so you can get that copied down in your notes. We're going to do 5 examples. So example number 1, the absolute value is already by itself. So we don't have to do step 1. Got it? Step 2 is to take whatever's inside the absolute value, and in this case, it's just simply the variable P. And we are going to take whatever's inside, and then this is where you set it equal to a positive and a negative. On the other side, the equal sign is a 9. So we're going to set the P equal to positive 9, and we're going to set the P equal to negative 9. You always set it equal to a positive and a negative of whatever's over on the right. And then the last step is solve. Well, this one is the most basic of basic ones you can get. It's already solved for you. So your answer is 9, negative 9. Okay. Number 2 example. Give you a minute to get it written down. Okay, step 1 is already done. Absolute value is by itself on the left, so we're good there. So now we are going to take what's inside the absolute value. We're going to drop the absolute value symbols, and we're going to work this twice, once set to a positive 4 and once set to a negative 4. And just as a kind of a put a pause button, you don't have to put this in your notes if you don't want to. I'm just explaining to you what absolute value is in case you've never had it before. Absolute value is if you have a number line and there's 0. If I say the absolute value of, say, 5, I mean it's 5 to the positive side and, whoops, I think I did 4 over here, didn't I? Sorry. It's 5 to the positive side and 5 to the negative side, because what absolute value means is how many steps away from 0 is it? So if I say, what is the absolute value of 5? You could go 5 steps to the right, or you could go 5 steps to the left. Both of them are the absolute value of 5. One just goes to the right and one goes to the left, but they're both 5 jumps away from 0. So when you have an absolute value, it always represents a positive jump and a negative jump. And that's why we can go from the original problem, when we busted into 2 problems and we set it equal to positive 4 and negative 4, we're now accounting for the negative and the positive jump, and we don't need the absolute value brackets anymore. And that's why when we go from the first step of that, just the problem being there, when we go to that step of breaking it into 2 separate problems, that's why we drop the absolute value signs and we account for that negative and positive jump by setting it equal to a positive and a negative, okay? So at this point, that's just kind of a little run back to what absolute value is. So at this point now, you've got two separate problems, right? You want to think of these two totally separate problems, okay? You want to work them both individually, separately by themselves. So let's work the one on the left first. So we need to get x by itself. It's currently being divided by 10. So the opposite of division is multiplication. So I'm going to multiply by 10. Whatever I do to one side, I always do to the other, so that x equals 40. On the other side, I also have my x tied up with the 10. So I'm going to multiply by 10 and multiply by 10. And I'm going to get x equals negative 40. Now your answer is not always going to be the same answer, just negative and positive, and you'll see in the next example why that changes. But for this problem anyway, your answer is x equals 40 and x equals negative 40. Okay. All right, let's look at this example. Give you a minute to get it written down in your notes. All right, so first step is to get your absolute value by itself. There's currently that +2 over on the left that we want to get rid of. So before we do anything, we're going to -2 from the left and -2 from the right, because I always do it on both sides of the equal sign. This cancels out, leaving me -1 plus p. And I try to kind of over exaggerate my absolute value signs just so I don't mix them up as ones. Equals 4 minus 2 is 2. Now my absolute value is isolated. So now I'm ready to break it into two separate problems. So I can drop the absolute value signs now, and I've got -1 plus p equals +2. And then I've got -1 plus p equals -2. Okay. And I'm going to work it twice. So since this is a -1, I'm going to add a +1 to both sides, leaving me p equals 3. And on the other side of the equation, I'm going to add 1 and add 1, leaving me p equals, now -2 plus 1, signs don't match, so I subtract and take the sign of the bigger. So my answer is -1. So this is a good example of where my two answers are not just like +3 and -3. Okay, they can be different. Any questions on that so far? Okay. Let's not do this example. I want to do a different one because I want to make sure that you see one kind of every kind. So I don't want to do this one actually. I'm going to give you a different problem. So let's do -2n plus 8, and that's in an absolute value, over 3 equals 2. Okay, in this example, we want to get the absolute value by itself. It's currently tied up in a fraction or being divided by 3. So I always get rid of fractions by multiplying the whole thing by that denominator. Whatever I do to the left, I do to the right. So I'm going to multiply the other side times 3. That's going to get rid of that, which is exactly what I wanted. 2 times 3 is 6. Now I'm ready to bust it apart into two separate problems and drop the absolute value. So I'm going to have -2n plus 8 equals +6. And -2n plus 8 equals -6. And it doesn't matter. I don't know. I don't think I have any. Well, my next example is like this, so that's good. But if this was, and it's not, so don't change this on your notes, but if this was a negative, it doesn't change anything. You still would set it equal to a +6 and a -6. So that doesn't change anything, okay? All right, so now we're working it twice. So when we work the first problem, we're going to subtract 8 from both sides. And when we do that, we get -2n equals 6 minus 8 is -2. Signs don't match, so we subtract and take the sign of the bigger. And then we want to divide off that -2 from both sides. And that gives me n equals, and -2 divided by -2 is +1. On the other side, we're going to work it again. We're going to subtract 8 and subtract 8. And that gives me -2n. That's gone now. And then -6 and -8 is -14. And then we're going to, again, divide by -2 on both sides, leaving us n equals -14 divided by -2 is +7. So there's your two answers for this one. Any questions on that? We have one more example, and I think we've pretty much covered everything that you would see on your homework. All right, this is kind of the hardest of the hard, and you have one problem like this on your homework. It's not necessarily hard, it's just you got to know what order to do things in. So go ahead and copy this problem down. All right, so I think I made the analogy in all my classes, but if I didn't, or if I did, you have to hear it again. And if I didn't, then this might be the first time you hear this. But I usually tell my students that when you're talking about whether something is a single expression, if you're multiplying two things together, multiply, think marriage, right? When two get married, they become one. So like, let's say if you have 2n, 2 times n, that's considered one term. They're multiplied together. They're married together. They're considered one. It's a stronger bond. When you put like and add 2 to it, think about that as like having kids, right? Eventually your kids move, they get married, they go away to college, they whatever, okay? They're easier to break off. So anytime you have addition and multiplication, you always want to break off your addition and subtraction first, because those are your easier to break off. Your multiplication is the last thing you break off, and that because that's that stronger bond. So when that comes in hand, or when that comes into play, is in this example. So looking at everything that you've got on the same side as the absolute value right now, you have this -1, right? And it's attached right here with this negative sign. So it's attached with addition, subtraction. So that -1 is kind of the easier branch to break off. It's not as strong of a bond as, say, the 9 times the absolute value. 9 times that absolute value is a much tighter bond, so it's going to stick longer. So the first thing we're going to do here to start getting our absolute value by itself is we're going to add a 1 to both sides of the equation, okay? And in doing that, that snaps this -1 off the end here. And it leaves us with -9. And then anytime you've got a number touching a parentheses or a bracket of any kind, it means multiply. And then inside our absolute value. And then -82 plus 1 is -81, because the signs don't match. So we subtract and keep the negative sign. Okay. Now we're ready to break that multiplication bond. So now we're ready to divide -9 on both sides. And when we do that, now we're left with the absolute value of x minus 10 equals -81 divided by -9 is a +9. Now our absolute value is isolated. So now we're ready to break it into 2. And so we have x minus 10 equals +9 and x minus 10 equals -9. And now you're ready to work it twice. So on the left, we work it by adding 10 to both sides. And that gives us x equals 19. And on the right, we're going to add 10 to both sides. And that gives us x equals -9 plus 10 is a +1, and those are your two answers for your absolute value. Okay, any questions on that? All right, for those of you at home, make sure that you took your notes in your 3-ring binder and go to the assignment, scroll to the bottom, click the Load in Cami button, and do the assignment on Cami, showing all your work and circling all your answers, and email me if you have any questions.